Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, empowering the world through engaging learning. I'm your host, Zach Memis, as we continue on with compTIA Net Plus. This is Ports and Protocols Part 2. Make sure you see Part 1. And our IT expert bringing us all the great information we need is Wes Bryan. Wes, thanks for coming on back.
Hey, thanks for having me here, Zach. That's right. We left you with a cliffhanger in Part 1. Remember, we were talking about in Part 1, we kind of set the stage, and I'd like to just recap just a little bit, right? Remember, we're talking about ports and protocols, right? A protocol is a rule for communication, right? A structured organization, if you will, rules for communication. And if you have a service that is needed, you know, you have a client computer requesting a service out there, both endpoints have to be speaking that same communication type, right? That's essentially what a protocol is, right? Now, the port is what helps us to identify that connection, where it's going, right? So, for instance, we talked about in the first episode, we talked about things like our email servers, right? If I'm going to send email to an SMTP server, its port, right, the port that it's listening out on, that's open, and it's saying, hey, you can send me your email, is port 25, right? So it identifies that logical endpoint of a connection. So I do want you to be aware of that. Now, continuing on, basically, we have quite a few more protocols that we need to talk about, right? We've got one service protocol, if you will, that's out there that is probably one of the most important. They're all important, Zach, but this really, from an administrative standpoint, helps us to reduce the complexities of addressing all of the computers that are across our networks, right? Now, if you're on a small network, it might not be so bad, right? If you got 5 or 6 computers, but can you imagine if you had 5,000 computers and you needed to assign an IP address to every single one of those computers, right? Well, if you're an hourly employee, that's just fine. You start now. By the time you're done, you'll probably have to start over again, right? It's like mowing a 1,000-acre yard with a push mower. By the time you're done, you need to start back over again. But we really want to try to reduce the administrative complexities, the nightmarish complexities of assigning IP addresses. And that's where something known as DHCP comes in, right? Now, in other episodes, we go more into depth on the DHCP process, but you need to know, again, the protocol, right? Dynamic Host Configuration Protocol. In fact, I got a little diagram here just as a real quick refresher if you haven't seen our episodes where we talk about DHCP more. All right, remember that DHCP, it allows dynamic host configuration. I love to break down the acronyms on this because in this acronym, it tells you what's happening. Dynamic. It means it's not automatic, but it just does mean things can change. All right, host configuration, right? We're going to send out some configurations and a protocol, right? We already know what a protocol is. We've established that, the rules of communication. So when my client computer, it comes online, right? It calls out to the network and says, hey, anybody out there got an IP address? My server responds back, right? The DHCP server, even your home routers do this, responds back, says, yeah, I have an IP address. All right. Now, there's more to it, but we'll go into the DORA process when we start talking about IP addressing and stuff, because it's really, really essential to how IP addresses are obtained, you know, in your modern networks, right? Now, I do want you to be aware of the port or ports that are associated with DHCP. This is another one where, unfortunately, there's just not a single port. There's a couple of them, right? Port 67 and 68. So do be aware of that for DHCP, port 68 and port 67. All right. Now, the next port that we have, or protocol, if you will, is one that you're probably using right now if you're watching us from your computer, right? And what do I mean by that? Well, what I mean is something known as HTTP. HTTP has been around for a very long time, right? HTTP is the Hypertext Transfer Protocol, all right? Hypertext Transfer Protocol, basically your web pages that we see today when you're visiting the IT Pro TV website. In fact, let me go ahead and show you. So I got the IT Pro TV website up here, and what we have in the background that's going on is there's HTML, Hypertext Markup Language, right? The Hypertext Markup Language is essentially the language that your web pages are written in. Now, what I have is I have a web client. The web client in this case just happens to be Internet Explorer. And for those of you out there that like different browsers, I'm not picking one over the other, Chrome, Firefox, Safari, if you will, Edge, Internet Explorer, all type of web clients, right? Well, the web browser, what it does is it actually connects to the web server on port 80, by the way, and there is a change to that too, and we'll talk about that in a second. And the web server essentially responds to a request. So my web browser here is going to connect to a web server and say, hey, I need that resource. What's the resource? Well, the resource is the web page. All right, and over HTTP, the web server responds to the request for that service and hands the HTML back to the web browser, which technically is the web client in this case. And then the web client, the browser, renders the HTML in what you see, the interactive viewing experience that you have. That happens over port 80. In fact, you know, we can actually kind of show you that. And we'll let the Wireshark go ahead and we'll basically launch it up here. And it looks like I'm minimizing it here. And I'm going to go ahead and I'm going to take the network adapter here and we'll just kind of capture some traffic, right? We're actually connected over HTTP to the web server. Let's see if we can see that port in action, right? So I'm going to go ahead and I'll apply my filter, TCP.port, and then equals 80. And we'll go ahead and hit that filter. And I tell you what I'll do. I'll go ahead and close the web browser down just for a second. And then we'll reopen it. And let's see if that generates just a little bit of unencrypted traffic there. I know Edge is using it a little bit there too. I'm going to go ahead and just see if we can't. We'll go ahead and open these back up here. Got to try to generate some of the traffic here, and that's what we want here. And let's see here. There we go. That's what I wanted to see. So good. I've got my filter in here, and I can go ahead and actually stop this packet capture. But what I want to see here is notice that transmission control protocol, all right? Remember we were talking about ports. The source port is coming from my computer. It's in that 49,152 to 65,535 I told you about. Those are the dynamic ports. Well, look, my computer is sending a connection saying, hey, it's coming from me, but notice what the destination is here. The destination port is HTTP. Right, so I can see that this is HTTP traffic, and we can see that right here just by capturing that information. And that's one of the reasons I tell you that it is important to understand these protocols. All right, now there's a problem with HTTP. HTTP is unencrypted traffic. It's another one of those ones that, yes, I know it's going to start sounding like a tinfoil hat episode here, Zach, but it's one of those ones that, you know, somebody could capture the information just like I did, and they could potentially see what's going on, and they can decipher what is going on with your communication. If there's any information in there that you don't want anybody seeing, they're going to see it. So one of the things that you'll notice is that this web browser, in fact, if you'll notice here on the website here, IT Pro TV's website, notice that we have this HTTPS, all right? Well, what's HTTPS? Well, we can couple HTTP with something known as SSL, the Secure Socket Layer, all right? So HTTPS is an acronym, and if you want the full name, it's Hypertext Transfer Protocol over Secure Socket Layer, HTTP over SSL. And what that does is that adds that public key cryptology, right? Like we were talking about SSH, I get the public key of the server. Well, guess what? We're going to start a session key 2, process it just a little bit different, but we're going to start a session with the server, and when we connect to it, what's going to go on is it is going to encrypt the communication, right? It's going to make sure that if somebody is out there with one of these, like Wireshark, and they're scanning the network, that they cannot see that information, right? That is port 443. That's what we want you to be aware of for the exam. And again, you could fire up something like Wireshark, and you can actually see the communications, right? That's port 443. That is encrypted traffic. Now, I want you to be careful with this one, because one of the things that I've told students in the past is that port 143 and port 443, boy, those are really, really close. And if you're getting nervous on the exam, I could see you making a mistake on those just because of how close they are. Do not confuse port 143 with IMAP, all right, and port 443 with HTTPS. Do not confuse them the other way, right? HTTPS 443, all right, IMAP port 143.
So Wes, is there a protocol to help us find out the state of our network devices?
This is a very, very useful protocol, all right, and that's something known as the Simple Network Management Protocol, SNMP, right? Now, SNMP is a way that, just like you were saying, Zach, that I can connect to various devices, routers, switches, if you will, servers, and if I've got the software set up right, they can actually send me, well, what things like configuration, how they're configured, if you will, and we can just basically monitor those devices. And I got a little example here too. And what you have is the Simple Network Management Protocol, and you typically have a management station. We'll talk more about the MIB databases and stuff in another episode, but again, remember the protocol itself, again, it allows us to communicate with our network devices and find out what their configurations are and what's the state of their health. Are they online? Are they offline? And this is a great protocol that you should be aware of, SNMP. Now, there are a few different versions. There's SNMP 1, which really shouldn't be used at all anymore. Even 2 has some security vulnerabilities. Really today, for security purposes, if you are going to use SNMP, you want to be using SNMP version 3, and that is port 161. So be aware of that. Now, there are other protocols that we can also use that allow us to connect over the network to other computers. And if we want, we can control them just like we're sitting at them locally, right? These are what are known as a remote connection protocol. And there's actually one that they call out specifically. There's all different types that there's RDP, remote desktop protocol. You have things like VNC, SSH allows you remote logons as well, right? But what we're talking about is Microsoft's proprietary, all right, Microsoft's implementation of a remote management protocol, and that's something known as RDP, the remote desktop protocol. We could actually see that in action. I'll tell you, let me show you here how we use that, right? So if I want to connect to another machine and I want to control it over the network, all I have to do is go down to our little search functionality here, and we could type MSTSC, and we can launch our remote desktop connection software, and I can make a connection. All right, let me make sure that I got the IP address right there, and then we can make a connection. Let's try that again. There we go. That's what we want. And I have to remember if I have my password right. All right, so I'm connecting to this machine right now, and this is another Windows machine that's on the network, right? And I just used RDP to connect over the network to it in order to, well, basically take control of it remotely. All right, and let me see here. We can potentially also see this in action too. So, we'll use Wireshark and show you guys these ports as well and why things like the ports are important. All right, so if I just basically look up any kind of connection here, or just fire up Wireshark again, we could probably, let me see, I want to say this is TLS. I might have that wrong, but let's try this. TCP port equals, and that is 3389. All right, now there we go. Yeah, we can see those. All right, so what we end up having here is in remote desktop protocol, RDP, when I make a connection, that other Windows computer that was listening out like a server, it's actually looking at port 3389, right? And we can see that right here, port 3389. So I want you to remember that on the exam, right? When it comes to remote desktop protocol, it allows me the ability to connect to another Windows machine, essentially controlling it as though I'm sitting locally at it, right? Here's the desktop of the machine that I'm sitting at. Well, guess what? Over the network, now you can see this little remote desktop connection bar here. I can actually connect to this machine and I can control it. I can work with it just like I was in or sitting in front of it locally, right? So remote desktop protocol, RDP, you want to know is port 3389. Now that's another one that I'm going to mention coming up a little bit later that also is really close, all right? So I'm going to mention it now. We'll get to it in a second here. LDAP, the Lightweight Directory Access Protocol, uses port 389. Let's be careful and not confuse those two. All right, so what else do we have here, Zach? The next thing that we're going to look at is what is known as, well, NTP. NTP is a port or a protocol that's been around for a good long while, and this is really about timing, all right? Network Time Protocol. All right, NTP is Network Time Protocol, and it's what we use for time synchronization. So let me show you here. Got a little diagram here. Your computers rely, their network communications, everything revolves around timing, right? It's one of the reasons we have that real-time clock on your computer, right? Like a metronome, it's the heartbeat of your computer. Well, when you're doing things like synchronous communications, I need to be able to synchronize so that we can send those communications in the right order, right? Well, NTP is the way that you do that, right? There's a lot of protocols that are really, really time sensitive. Things like the Kerberos or Kerberos, if you will, authentication protocol. It's very, very time sensitive. So you need to make sure your computers, our devices out there, need to make sure that they can rely on what's known as a reliable time source, and they do that over NTP. Understand that NTP uses port 123. And I went ahead and just kind of drew a little diagram up here because we think about connecting out to a time server and we synchronize our time, right? Well, there's actually a whole entire hierarchy when it comes to NTP. And when I say hierarchy, I mean it is massive. The top part of the NTP hierarchy are what are known as the authoritative clocks, if you will. These are things like your GPS clocks, your atomic clocks at things like the Naval Observatory, right? U.S. Naval Observatory, if I could say that right. They've got time clocks. And then you have your primary time servers that are directly connected to those clocks. And then they go down in the layers from there all the way to where your local time source is. Kind of an interesting fact, when your computer, when your Windows machines, when they come online, they actually reach out across the internet to time.microsoft.com or time.windows.com, one of the two, I can't remember exactly, but they're going to reach out and they're going to actually do time synchronization. Time synchronization is important on your network, so know what NTP is. All right, so the next one that we have on the list, moving on down the list, is something known as SMB. That's Server Message Block. Server Message Block is inside of Windows. I will tell you that this is essentially a protocol that allows you to connect to file shares, shared resources within Windows networks, right? So if I have a shared folder that I've dumped my files in and I want people to be able to connect to it over the network, well, they're going to use something known as Server Message Block. Server Message Block, I can give you an example here. I got one on my screen here, is when you do have those shared resources, like maybe it's a file share out there, right? We've got a folder out there on a Windows network, and we're putting all our documents in there, and we're allowing people over the network to connect to it. If you're sharing a printer over the network, guess what? In order for your client to print to that shared computer, it's going to use SMB, right? Server Message Block inside of Windows, as well as serial ports too. That's why I got the COM port up here. Some of you guys may be coming back over from A+. Remember that a COM port essentially is a serial port. Now, there are interoperability protocols that I just want to take a second and I want to make mention of. There's something known as Samba, all right? And you can kind of see SMB, Samba, they're kind of playing on the word. That's what you would use for Linux machines, Unix-like machines to actually interact, if you will, with SMB shares, right? SMB actually started off originally, it was a version of something known as CIFS, that's the Common Internet File System or standard, and Microsoft made a ton of changes to it, so there's actually quite a few different versions of it. Again, it's an application layer protocol, and it uses, when it's using TCP, Transmission Control Protocol, it uses port 443, but I've actually seen it go across. As you research it, you might see that it can also piggyback not across just TCP/IP, but it can piggyback across things like NetBIOS. And if it uses the UDP ports, you're going to see UDP ports 137 and 138. All right. Now they don't call out that port as far as what the objectives are. 138 or 137 and 138, but I do want you to be aware of it just in case. I'm not sure if they're going to show that on the exam, but if they do, you're there. You'll have it. There are other ones that are out there that are like this too. I mean, this isn't the only one. Windows isn't the only one. You've got Network File System, NFS, if you will. You've got things like, it's not Apple Talk, it's the Apple Filing Protocol, AFP today as well. So be aware of those likewise. All right, so again, just kind of running through our list here. Some of the next one that we have to talk about, I kind of briefly mentioned when I talked about RDP, Remote Desktop Protocol, and that was port 3389. Well, LDAP, Lightweight Directory Access Protocol. Got an example of this here. What this allows you to do, and that should not be an SMB client. Sorry about that. Let's go ahead and fix my slide on the fly. This is an LDAP client, all right? And what this allows you to do, the Lightweight Directory Access Protocol, it allows you to connect to an X.500 based directory service. it essentially allows you to communicate with a directory database and directory databases, directory services, if you will. They're common for storing things like usernames and passwords. So if you're, let's say, in an Active Directory domain, right, and you want to connect to the domain controller, the directory service, the directory database, well, guess what? You're going to do it over LDAP, right? And that is port 389. And I made a point to try to differentiate that. It's another one of those ones that you might get wrong on the exam if you get nervous or just not paying attention to the key words here. Because remember, RDP, Remote Desktop Protocol, that's port 3389. LDAP, industry-wide standard. I just happen to have it associated with Windows Active Directory. Please understand, it's not just a Windows-based technology. That's LDAP, Lightweight Directory Access Protocol, and that's port 389. Very easy to get wrong, but just as easy to get right. So even if you're a little nervous there, pay attention to those questions on that exam. We want you to pass them. All right. Let's see here. Now, there is an issue with this protocol in the fact that if I am connecting to that directory service, I want you to think about what a directory database, not only does it have usernames and passwords, which is very, very important on your network, right? Especially from a security standpoint, but it basically has, it's a database of every object within your network. Printers, servers, services, you name it. I mean, Active Directory, you know, as an example, can scale up to 1 billion objects, could be in one little file, right? So we want to keep that protected. Right, so port 389 might not be the way that communications again would be protected. But if we implement LDAP over SSL, just like with HTTP and HTTPS, we can now encrypt that communication. So if you will, they have what's known as LDAP-S. And again, it's a secure LDAP. And let me show you here. What LDAP-S is, Lightweight Directory Access Protocol. Again, Lightweight Directory Access Protocol over SSL. And it, again, couples that public key encryption with the communication with the database so that basically it's confidential, right? Port 636, all right? There are 2 different ports for these, all right? So definitely know a little bit about those ports, right? Essentially, you're using an SSL certificate to secure access to the directories over a TCP/IP-based network. All right, let's see, Zach. We got a few more, a couple that we haven't talked about yet that I want to just go ahead and mention. Session initiation protocol, and I'm kind of going out of order here, but session initiation protocol, and then something known as H.323. All right. Let's start with the one that was actually comes from the ITU, the International Telecommunications Union, and that is I want to say 232, but it's 323, right? This was initially used for video conferencing, but later on it was expanded, and now it's used. It's a convergence technology, which means it converges audio, video, and data, and it basically for those type of communications over a TCP/IP-based network. So we use it in things like video conferencing, and there is also another use for it. We use it in voice over IP, just as well as we use session initiation protocol. Session initiation protocol, again, is used for voice communications initially, but again, later it was expanded, and it's now used for more than just voice communications. We can use it for things like video, instant messaging, presence, right? If you've ever seen like a listing in your Skype where it says, hey, guess what? This person's online, or this person's away, or this person's busy. Well, guess what? You can use things like the session initiation protocol for that. Let's see here. A couple of ports. SIP, Session Initiation Protocol, uses port 5060 as well as 5061. The last one there, the H323, I do want you to understand that that's going to use port 1720. Again, port 1720. Now, the last couple of things that I want to talk about, they mention are protocol types, all right? And I've kind of been talking about this throughout the last 2 episodes, and I've been mentioning things like Transmission Control Protocol, and I've also mentioned things like UDP, all right? What we're talking about is on a network communication, sometimes you need a guaranteed reliable connection. I need to guarantee that when I send that information, it's going to get to that endpoint in the right order and it's going to be processed the way it should be. I I can't tolerate errors, right? I got to have that reliable service. Well, with a reliable service, there's a lot of checks and balances, things that have to go on. And in some cases, you don't care if a packet gets dropped, but you need it to get there fast, right? That would be a connectionless service, right? Where you need it a little bit more streamlined. And that's where two transport protocols come in. One known as Transmission Control Protocol, TCP, and the other one known as UDP, the User Datagram Protocol. Let's go ahead and I tell you what, we'll start with TCP. All right, when I talk about TCP, there's a reason there's a little bit of overhead. This is a connection-oriented service, ensuring reliable delivery. All right, and that's like me sending a piece of mail to Zach. All right, and I want to make sure that Zach gets it, right? So what do? I want delivery confirmation. I want a return receipt. And if Zach doesn't get it, I want him to call back and let me know, I didn't get that package. I need to resend it. That's essentially what Transmission Control Protocol is going to do. All right, but in order for that to happen, we have to go through a certain handshaking process. And I want you to know that about Transmission Control Protocol as well. To set up this reliable connection, we go through a three-way handshake. Let me show you what I mean here. All right, so in the TCP three-way handshake, we have what's known as a synchronization request. Remember earlier we were talking about time? Well, time is important, right? I'm going to reach out to, I say it's going to be the computers that are doing this, but I'm going to reach out to Zach's computer and I'm going to say, I need to send you some reliable or some information in a reliable manner. So we're going to send what's known as a SYN packet. It's a synchronization request. Zach's computer is going to hear it, and it's going to respond back. Okay, yeah, I acknowledge that. You just sent a synchronization request. That's called a SNAC or a SYNAC. The synchronization acknowledgement, all right, packet. Final process, right? Final part of this three-way handshake is an acknowledgement back to his computer that, yes, we've established that communication. But it goes a little bit farther than that. It doesn't just stop there. Transmission Control Protocol does something kind of interesting. When you've got a large amount of information that you need to send, right? We've established the three-way handshake, and now we got to send communications between Zach and my computer. What's going to happen is the TCP is going to take that package and it's going to break it down into smaller, more manageable pieces, right? This is what's known as segmentation. And these are going to become segments. All right, now it's going to go a little bit farther than that too, because it's going to take each one of those pieces and it's going to sequentially number them. Now, please don't take 1, 2, 3, 4, 5, 6, 7, 8. These could be large numbers, right? But what it's going to do is it's going to sequentially mark them, right? So now what we have is segmentation and sequencing, right? Well, why are we doing the segmentation? For more reliable delivery. Why are we doing sequencing? Well, sequencing works like this. Let's say that I'm the source of the communication here, and let's say Zach is the destination. Well, notice something. Zach's computer in my diagram here has received packet 1, packet 2, or segment 1, segment 2, segment 3. Notice what's missing. Segment 4. All right, so what Transmission Control Protocol, and this is part of the handshake process, Zach's computer is going to say, hey, hold on. I'm missing 4. I got 1, 2, 3, but now you're sending me 5. We've got something wrong here. So what he's going to tell my computer, I'm missing segment 4. Can you resend that? And my computer will resend segment 4, and then it'll start back in the process of all those sequence segments behind it, right? So not only does it ensure that it's broken down into a reliable manner, but then when they're processed on the other end, guess what? They're processed in the right order, right? Guaranteed. First of all, connection-oriented service with reliable delivery, right? It's your delivery confirmation. And that is unlike something known as User Datagram Protocol. All right, all of that extra stuff that's going on takes a little bit of overhead, right? Your computers have to do this, right? They have entire offload engines for TCP to maintain communication, especially when you have hundreds and hundreds of thousands of these communications. Sometimes you just need things there fast, all right? And that's where User Datagram Protocol comes in. I want you to think about, right? Think about the, well, here in the States, right? If I need to mail a snail mail and I don't need to go to the post office and do all that delivery confirmation, return receipt, right? What do? Well, here in the States, we find one of those blue mailboxes, right? And I take my letter, and I throw it in it, and I'll walk away. That's best effort delivery. No guaranteed delivery, but you don't have all that overhead. My time isn't going to be spent on delivery confirmation and filling paperwork out, right? I'm just throw it in the mail and go. My time's money. Well, that's the same thing that you use with UDP, right? If I need to stream data, right? I don't care if there's that football player that's running into the end zone. I don't need to pick up a couple of little segments that maybe we lost, right? No, just let them go and let's just keep going, right? It's streaming information. I need it there fast, and I cannot worry about rebuilding it, right? File transfers, I want to rebuild it. I want to make sure that the data state maintains its integrity. In something like streaming media, if we drop a couple of packets, well, you see a glitch in the video and we move on, right? So there are reasons why you would use a connectionless service, right? You can also have things where the application has built-in reliable delivery. Well, then there's no reason to use transmission control protocol. You can let the application handle it. All right. 2 protocols there. I know we're getting out of time here that I also want to mention. One is ICMP. That's the Internet Control Message Protocol. Internet Control Message Protocol doesn't actually send information, right? Like these transport protocols, UDP and TCP that we're talking about. This is actually for things like sending diagnostics information, flow control, error messages. If I'm sending too much information into Zach's computer, and Zach's computer, the network adapter, for whatever reason, gets overwhelmed, it sends me a squelch message and says, hold on, slow down. If you don't slow down, I'm going to start dropping packets because I can't process them fast enough, right? So it does flow control. Some of the utilities that you use actually use ICMP as well. Ping, Packet Internet Groper that we use to test communications between 2 endpoints, it uses ICMP to send those ping packets. TraceRT, where we determine the path a packet takes from source to destination, guess what? It also uses ICMP. So we've got protocols out there that don't necessarily transmit data or are used to transport information as they are used to do things like manage and diagnose issues within the network. Last but not least is IP. We've got a whole entire section that we're going to go into the Internet Protocol and how we obtain and what IP addresses are. Just know for now that IP, it's responsible for your addressing, right? Source and destination, where do I send that traffic to? Where did it come from, right? We've got an identifier just like you have in any kind of mail system. You have a source and destination address. IP is your source and destination, an electronic packet, right? The electronic envelope, if you will. It is a connectionless protocol. It has no clue how to get the information where you need. It just says, I stamped it with an address. Now we got to worry about, the network has to worry about that. That's the last one of these protocol types that we want you to be aware of. Keep in mind, some of it's just memorization. I do understand that. Some of it's theory. Some of it's, hey, you got to understand what the protocols are doing. Sometimes it's just a matter of writing things down and just memorizing and committing it to memory. Don't let it worry you. If you keep practicing it, you're going to get these protocols down, and before you know it, it'll be a thing of the past.
And if you keep watching the videos that Wes is creating here, I'm sure you won't have any trouble. Ports and Protocols Part 2, there was a Part 1. Watch them both. Watch everything in the compTIA Net Plus series and in the course library. Check out the hundreds of videos that are there, and they're all created for one purpose, to help you go further. And thank you for watching IT Pro TV. Tell everybody you know about it, because you know what? They're going to be very happy that you did. I'm Zach Memis.
And I'm Wes Bryan.
And we'll see you soon.
Thank you for watching IT Pro TV.